Hello and welcome back to a new video here on the Ludwig Fusel channel. Now in today's video we're going to talk about Conan 2.0, the package manager for C and C++ developers. Now if you are a long-term subscriber or you searched for Conan on YouTube, you probably already maybe have seen my other video. I already did a video on Conan. However, this video that I've already done is outdated. So if you have watched that video or if you're already familiar with Conan 1.0 and now want to switch to Conan 2.0, this is the video to go for. The old video, it's deprecated, it only works with Conan 1 and any version of 1. This is now the proper video for Conan 2.0, not actually even Conan 2.0, this works from Conan 2.0.4 upwards, but this is the new video. This is the new video where we're gonna do it full chain on again with remake and everything works again. Very important. That's it. However, it's not required that you are coming from Conan, right? If you're coming from a different package manager or haven't used the package manager at all, it's also fine if you're watching this video. Because what I'm going to do is I'm going to explain everything from the start. I'm going to explain to you what a package manager is, what C and C++ is. No, that's something that you should already know. But I'm going to start with the basic minimum knowledge that you need to know for a package manager. Without any further blah, let's get into it. So, alright, we want to talk about Conan. And Conan is a package manager. What is a package manager? Well, it is exactly what the name suggests. It is a manager for packages. So a manager is this little guy here. He doesn't look like a senior manager. No, it's not a manager like from the business standpoint. It's a manager that handles something. It is a manager, a tooling application that manages packages for you. What are packages? Well, with packages, software packages are kind of like meant. It's also standing here, software package manager. And how can you see a software package? Well, basically, just to simplify things, it is an external library, a third-party library. You could even go further and see your own software that we are building as a package, because that's really what it is. And this is actually how far you can even go with Conan. However, for this video, I want to make it as simple as possible. Today, we're going to use Conan to consume other packages for our project. So we're going to use Conan to pull in external libraries into our project. Now, do you really need Conan? No. Of course you don't need to use Conan. There are other ways of handling external dependencies. For example, how I have always done that, I have always downloaded the stuff from source, like Crypto++, ASM, FreeType, all of these like big monolithic software projects. When I previously integrated them into some of my projects, I have downloaded them from GitHub, their webpage, wherever the source code was available, extracted the zip archive, used CMake to generate a Visual Studio solution, and I went into Visual Studio, and then in Visual Studio I said build the project, and Visual Studio has compiled everything. Maybe I've tinkered a bit around with the settings, and after that I have found like the binaries, the headers, and the PDB files, and I have copied them to one big folder, and that folder has then been copied to my repository and was then pushed with my repository to Git. Now, this is a very simple and effective way. You don't need any tools. It's directly in the project. It's all set up with one build system, and you are completely going for that without a package manager. However, there are many things that are not wrong with that solution. It's not that this solution by manually compiling is wrong. However, there are a few things that you might want to consider in doing differently. Now, the problem that you have if you are copying the data to your repository is, first, you are filling up your repository. Second, you need to make sure, especially if you're on open source and new to software development, you need to make sure that all the licenses are correctly for the external dependencies, especially if you're kind of like redistributing the headers within your repository. And second, you really don't want to have binaries in your Git repository. This is something that I personally say I don't want that. We're going to have it anyways today, but normally what I say, every binary shall be automatically downloaded in the correct version and used. And I mean, it also has fallbacks there if the binary is no longer available because the project is shut down, the web page is offline, you can no longer download it, but that's a different story. That's not the standpoint from where we are starting to that. Because nowadays software is 90% of the time on GitHub and available. There are also other problems when you are like manually compiling them and copying them in. the most big problem is the time that it takes. If you are really manually downloading packages, right, external libraries, you need to find them. You need to search the internet. Where are they located? What is the correct package for the source so that I can compile them? Download the source, manually open this up, make you familiar with the build system that they are using. Are they using CMake? Are they supplying a direct Visual Studio solution? Are they using any other exotic build system that might need to be downloaded and manually integrated and learned by you so that you know how to get the solution or the project compiled, the library compiled. You need to get familiar with that. You need to run the build steps. You need to check if the build steps were correctly. You need to know which files after the build step needs to be copied. You need to copy them all, or most of the time, especially with like CMake projects, need to copy them from multiple locations, right? CMake it sometimes generates headers that are in different folders than the actual includes. You need to make sure that you are copying the right one, the config headers as well, that you are copying over the library files, maybe even the PDB files if you want, and you need to really make sure that all of this is correctly copied, correctly packaged in your repository, and that takes time. Quite some time. It already takes me quite too long to talk about it, but that is always something that takes time. And every time your project changes or the external library changes, you need to redo that. You need a new library, screw it, get it in. The new library didn't work, delete it, get the other one in. Oh no, I still want to have the other one because the next one that I tried was even worse. You need to redo that again, delete the newly created one, regenerate the other ones, and you need to copy data around. You have really waste some time in just waiting, copying, and thinking how other projects work instead of getting to work and using the libraries that you want to use. And also, every time the library gets updated, you always have that work that is associated with that. And that is why we want to use a package manager. In this case, it's Conan, because Conan does that all for us under the hood. We basically just tell Conan, hey, I want to use Crypto++, and Conan makes sure to download Crypto++, make sure to compile Crypto++, make sure to copy the right files from Crypto++, make sure to supply your project the right paths, libraries, dependencies, whatever, so that everything is done. Same here, again, I didn't mention that, but dependencies, right? If you're, for example, using Azure, whatever you want to call this, for like networking stuff, and you also want to use then like OpenSSL, you need to have like two big projects. And if some other project requires Azure and OpenSSL on a normal build chain, especially with CMake, it's really hard to get this all done. Conan does this all under the hood. Conan automatically then downloads, compiles OpenSSL, downloads, compiles Azure, and then compiles the library that you actually requested. And then it gives you an output. Hey, actually you have, by requesting one library, used 3. And that's all something that's still also handled by Conan. And we don't need to care about that. We just say, that dependency is what I want to have, and we get it. Now, let's actually get started in diving into Conan so that we know how to use it. Now, what you want to do is you want to start by downloading Conan. Conan is not something that you download. Conan is something that you install with pip, so it is important that you have Python installed. That's really important. I would recommend just basically globally installing Python. If you have Python globally installed and you maybe want to make this your coworkers a bit easier, you can install Conan with pip for the whole system. And if you are a system administrator and you're kind of like using Microsoft Intune or Active Directory, I would also highly recommend that you are basically supplying one script that is installing all your company's pip dependencies in an administrator prompt so that they are available for the whole system and the whole user. So what we also do this is we open an admin CMD here. If you do not have admin access on your computer, it's also totally fine to install this just to your user. Just be aware that it's then just going to be available for your user. All right, so now what we want to do is we want to copy that command here and we want to insert this here, pip install Conan. Now this is going to install all the Conan dependencies and then installing Conan itself, and then it's going to greet you with successfully installed Conan 2.0.4. It's important that you have 2.0.4. If you already installed Conan, you can do a quick check with Conan version that you really have version 2.0.4 installed. And if you are, I think there's like this force reinstall, something like that. And if you are doing like force reinstall, it is uninstalling all the dependencies and reinstalling all of them. If you do a force reinstall, then you just are sure that you're on the right version. I'm not a pip expert. There's also like a pip upgrade Conan, but yeah, force reinstall is also doing the trick, right? So yeah, after you've done this stuff, you should be greeted by Conan version 2.0.4. If something does not work, you need to consider your friendly Python installer guy, but I'm not a Python guy, so yeah. Now that we have Conan installed, we are ready to use Conan. How can we use Conan? Well, we can use Conan by creating a project which shall use external libraries. Now, one really important thing is Conan is not a build system. Conan is just a package manager, so we still gonna need something that's gonna handle building our project. So before we really can get started with Conan, we first need to get a project up and running. How can we get a project up and running? Well, I have an empty instance here of Visual Studio Code, and what I want to do is I want to quickly just create a bit of a folder structure. I'm going to have a source folder, and inside of that I'm going to have a main.cpp, and the main.cpp just for the example purpose is just gonna do a quick stdc out hello world here. And that's it. That's everything that my project shall do for now, before we then gonna pull in some external libraries that are gonna do stuff for us. Now, how can we build this? Well, I'm a Visual Studio guy, so I want to generate myself a Visual Studio solution. How can we generate a Visual Studio solution? We need a project system or a build system for that. I'm going to use Premake here, just the Windows version. We're not going to get fancy today and download a Linux version of that. So what I want to do is I want to maybe put Premake in its own folder. So let's create a new folder, maybe call this, let's call this vendor in here, and inside of this vendor folder I do want to put in Premake, or do I want to, I'm just going to put Premake now in the root folder because of multiple things. I just want to put it in the root folder, so let me quickly copy the premake5.exe from here to there. Now we should have premake5.exe in here, and if I now do Premake 5, yeah, I can actually use Premake 5. Interesting enough, it's not complaining. Yeah, because I didn't supply an action. So if I would do Premake 5 years 2022, it complains that it does not find a Lua script. So let's do Premake the favor and create a Premake 5.lua script. And since this video is not about Premake, I am just gonna copy their minimal working example here from Premake. You do not really need to understand how Premake works. It's just now here used as a tool. I do want to do a few changes, and I'm going to tell you how this is working. Now first we need the workspace. This is basically a Visual Studio solution called Conan tutorial, and this is going to use debug and release as a configurations. Architecture is x64 that I want to specify. Console app cpp. Target directory is going to be binary build configuration bin. I like to put this in the bin subfolder and call this not bin, like to call this one build. This is basically the output where the exe files are going to be put. objdr is the intermediate directory for the object files, and I want to put them into obj, just simple as this. I think it's called objdr. objdr, there we go. The next thing that is specified is C++. However, C++ is not sufficient enough for me. I also want to have the CPP dialect, which is the CPP version, which is CPP 20 in our case. So CPP 20 like that. Files is also something that I want to modify. First of all, I want to tell where this project is located. The location is in the source directory, src. There is our code, so that's what I want to do. And to also give this a bit more flexibility, I'm also going to say that I'm only going to put in my header files and my C++ files from the project's location, not the overall location. This is something that shall be done explicitly. Now the next two things are just for debug and release configurations with the default macro symbols on and optimize on. And what I tend to do, not file filter, is to also clear these filters to make sure that I'm not gonna do something. This is something that I would recommend to any Premake user, that you always are wrapping your filters in like that. This is basically resetting your Premake filters. If you are always following this convention, you're not at some point gonna get headaches why your properties are not working. All right, so this is everything that we should need to generate ourselves a basic Conan solution, so a pre-made solution. So that's everything that we can do. Let's run this. Now we have the Conan tutorial.sln and the hello world.vcx project. So if I do Conan tutorial.sln here in the console, it should open up Visual Studio and we should be able to run the project. And after that, we can then integrate Conan into our project. Now again, I am at some point going to provide you a template so that you not need to do all the changes, because it's already bugging me quite a while. I want to have a nice GitHub template so where we can always start on, especially if we are following your video idea or not my, actually somebody else recommended this to me already. I already had the idea still in my mind. We're going to do some projects in the future as well, because somebody told me that this really hits. The people like it if you do projects. But yeah, here you can see Hello World, it works. All right. So now that Hello World works, we want to integrate Conan. Before we want to integrate Conan, I want to first make sure that this repository is cleaned up. So git ignore is quickly added here so that we can remove everything that's not required for Git, because we are generating stuff on the fly. We are generating our solutions, right? So everything Visual Studio generated shall be removed. So the .vs folder, this is not required on Git. This is just a temporary folder. Every solution file is not required. So let's remove the SLN file. There it goes. And in the source folder, we have the VCX project and the VCX project.user. This is also what we want to remove. There's also a .filter thing. VCX project, and VCX project.user. There's also a VCX project.filters or filter, but I can't always remember that. And since we're not using filter, it's for now fine. Right, next thing that I want to remove is actually the build directory, because we do not need the object files there. We don't need the object files, we don't need the exe, we don't need the PDB, we don't need that on Git. So this is basically our build output, and our build output that I want to remove is basically everything that's in here, and it's called build. All right, so now this is all strapped down, and now we can start integrating Conan. Now, why would we want to integrate Conan? Well, we want to integrate Conan because we want to have external dependencies. So what external dependencies can we use? Now, in general, any library will work. However, not every library supports Conan. There is a way to actually also add libraries that are not supported, but then you need to be a bit more an expert in Conan and know how to actually write these so-called recipes that actually tell Conan how to compile a library. But if this is the case, you can just simply ship the recipe with your repository and install it on the machine on the fly, and then it can be used. That's basically the idea. However, that's not what we want to do. We want to find a repository or a project that can be used straight away with Conan. You can do this by clicking on Conan Center. If you're going to go to the Conan Center, you're going to find 2 million different versions of libraries. It's, of course, not 2 million libraries. It's versions. And the version is kind of like a pre-compiled version with like an operating system, compiler version, and architecture and target. So for example, like Windows, Visual Studio 2022, 64-bit release. And this is basically then counting here as a version. But you can see it's quite a remarkable number. Now, what do we want to do? Well, I talked about zlib, but I don't want to use zlib. Actually, let me use something like FMT. FMT is something that is a bit more useful, smaller to compile, and not. I mean, zlib is also small, but something like Boost would be a bit too big now, or OpenSSL. They take always a hell of a lot of time to compile. So what I really want to use is I want to use FMT. It's basically just a formatting library to printf. You can also use printf directly in there, which is just a bit cleaner than stdout or standard formatting. Most of the time it's used like for logging libraries, like spdlog is using that, which you could actually see. If you go to use by, you can actually see what is using FMT. You can see here spdlog is using FMT. If I go to spdlog, you can see that dependency is FMT. So that's nicely linked here. So actually we could even use, maybe let's even use spdlog so that I can actually show you that actually if I just use spdlog, it will automatically pull in FMT as well. Yeah, that's I think a good idea. It is in theory, I think both of them in theory header only, but we don't want to have the header only version, and by default we also don't get the header only version. We need to manually configure this, and that's actually fine, because header only, why would you use header only? Header only is just for people that just want to drop one header in their project and say, haha, done, I'm finished. But we want to use the proper version that's compiled and speeds up things. All right, so how do we now get this SPD log listed here in the Conan center into our project? Well, we need that string. You can see there's like this copy it now button, and then it's copying that string to the clipboard. And that is in theory everything you need to add a new project to your, or a new library to your project, if everything is set up correctly. However, we haven't set it up everything. Currently, we have no support for Conan in our solution. So before we can actually take the step and integrate SPD log, we need to first integrate Conan. Now, how do we integrate Conan into our solution or into our project? It's actually not that hard. In general, we do need nothing in here in general. In general, what we can just do is we can run the Conan command in here with one of the separate actions. The action that we want to use is the action install, and what we want to install is the current project, and then we're going to get an error. Conan file not found. Now, what does that mean? Well, by default, Conan dependencies are listed in the Conan file. In this case, it's the Conan file.txt. This is kind of like the default one that it tries to find. However, we are not going to use that one. We're going to use the modern version of Conan. The modern version of Conan is a Conan file.py, a Python file that's describing that. At the end, you could also use the txt file. The txt file is like the old version of doing it. The Conan file.py is a bit more modern. It allows you to do a bit of conditional checkings, or in theory also like importing your own stuff, and you can conditionally check, oh, am I on Linux? Yes, I'm on Linux. Use that library on Linux, but not on Windows. And that's why we're going to use the Conan file.py, so that, yeah, we have a few more options. So what do we now type into that Conan file? Well, I'm just gonna start with something so that you know how it's laid out, and you see what's going on. Now, first of all, we need to import something, and basically what we're gonna do is we're gonna, from Conan, import the Conan file, because that's what we're gonna do. You can see, since we installed it with pip, we have like the full hints of what this actually is. We can hover over the base class for all package recipes, and so on. And what we then want to do is we basically want to write our own class on top of that Conan file. Now, how do we name our class? Well, in this case, I'm going to call this one Conan tutorial recipe. And then this is going to be based on Conan file. Now, why did I call this recipe? Well, because the Conan file is actually a recipe. The Conan file is a recipe on how our package is built. And I already told you that packages are like external libraries, but you could also see your project as a package, and that's exactly what we are doing. We are basically writing a package for Conan, but we are not kind of like supplying a way to build our package. We are just kind of like, yeah, providing a way how our package itself is kind of like is kind of like laid out with all the dependencies, so that Conan can go and resolve the dependencies for us. Now, a Conan file or a recipe does need a few by default things that we need to do. We first need to provide it the setting values, and the setting values are basically the values on how our project is kind of like dependent. So we are dependent on the operating system, then we are dependent on the compiler, then we are dependent on the build type. The build type is like debug release, and we are dependent on the architecture, so x64. This is basically just telling what different settings are kind of like affecting our project and which settings are passed on. Don't ask me why you always need to do this. Maybe you can change a few things here, but normally you would just want to put this line in as it is. Now, if we are providing these settings, we are basically telling Conan on kind of like what are the variable things that can change on our project systems. And what we now need to tell Conan is what we're actually using by defining a function. So we can define our function here. The function is called requirements. Here, member function here of the class. And what this requirements function is basically doing is defining the requirements that that this Conan file, that this project has. Now, this is basically called by Conan at the right time before Conan kind of like starts resolving the dependencies. Conan is going to call our requirements function, and we then have our options to actually go in and correctly set up all of our dependencies. Now, speaking about setting up dependencies, how do we set them up? Well, we set them up by calling a function on ourselves, and we're going to call the function requires, because we are requiring a other package. And you can already see that the argument is a str_ref, so a string reference to the package that we want to have. And the string reference, you guessed it, it's exactly what we got on the Conan Center, which you can copy here. And that's the only thing that we need. Paste this in here, and our very, very basic and first Conan file, Conan recipe, is finished. And now what we can do is we can try a Conan install again. Now, you can see, if I do this now, the error that we had previously is gone. However, we got a new error. What is that new error that we got? Well, the default build profile doesn't exist. Now, Conan works on a profile base. A profile is basically defining what operating system you kind of like want to generate the project for, which C++ version you are using, which compiler version you are using, and all of this stuff is basically defined in the profile. Now, what you can do is you can automatically detect your default profile by running that command, Conan profile detect. If I run that one, it will do stuff and detect these settings for your profile. Architecture, 64-bit, build type release, compiler, Microsoft Visual C compiler, CPP version 14, runtime version dynamic, compiler version 143, operating system Windows. Now, by default, this should work. However, there are a few things that I'm not happy with. This CPP standard has been set to 14. However, we are using CPP 20, and the problem is if we are using a library that is later or is not compatible with CPP 14, or maybe requires CPP 20, this will fail. And it cannot be integrated then because we are using CPP 14. So this is something that we want to fix. You can fix it by basically control-click here on that link, and then it will basically open up the profile that has just been created. And you can just set this one here to 20 to basically say, all right, no, I want to use C++ 20, and I'm basically directly committing and saying, use that version here. All right, so now that I have set this up all correctly, I can try this again. Conan install dot, and we can see what it will do. And boom, it failed again. However, it has done a few more things. If you consider the output that we got now is we get like this host profile and build profile. The host profile is basically our system, and build profile is kind of like the profile how it's used for building our project. And down here now, it is kind of like computing the dependency graph. You can see that the graph root is our Conan file.py, and the requirements is FMT. As I told you, spdlog is using FMT. So actually, if we are including spdlog, we are using FMT. And you can see that both of them were not available. So it downloaded them from Conan Center. It automatically found them. Then it computed the necessary packages. So it has done a few things here that were basically evaluated, and then it at some point again had some requirements, and you can see that both of these requirements were missing, and then we got an error missing binary for FMT and spdlog. So basically it was not able to find a binary, pre-built binary for FMT nor for spdlog on the Conan Center. The general idea of Conan is that it supplies pre-built binaries for you. And now you are screwed because you don't have the binaries, because basically Conan doesn't compile for Visual Studio 2022. If we would go for Visual Studio 2019, we would be probably fine and it would find the binaries. However, we haven't found the binaries yet. Is it a problem? Actually not. We can actually tell Conan to build this on demand. So we are basically going to give Conan another option here. We're going to give it the option build, and it shall build all missing dependencies by --build, and then missing, we basically tell Conan that if it cannot find a binary for that, it shall build this on our computer. So if we're doing it like that, the command will take way longer. and you can actually now see it's downloading, answer copying. Now you can see that actually CMake is running. There's also something, if something fails there, like the command CMake cannot be found, you need to manually install CMake to your machine. The general idea of Conan is that it installs CMake on the fly. However, some old packages are not written correctly and do not install CMake on the fly. So if you ever get any issues, just install CMake. If you have on a developer machine, you should definitely have CMake there anyway. So yeah. Now you can see FMT has already been built. Now you can see it's actually currently building SPD log. And this is going to take a few seconds. And now you can see that we are getting a nice prompt install finished successfully, which means that the Conan command has now successfully been executed. And we have all of our dependencies installed. And not only that, we have gotten a hell of a lot of file madness in our root directory, which is bad because we don't want to populate our root directory with some carnage. And I don't even know what that carnage is, like deactivate Conan build.bat, deactivate Conan run.bat, Conan run env release with a few cryptic outputs that are going on here, Conan run, build environment. There are a few things that are generated by Conan by default, and they are basically just dumped into your directory. And if you are later on going on with actually getting the required dependencies for pre-make in, you're getting even more file carnage on your root folder. So that's something that you definitely do not want to have. So yeah, what I want to do is quickly delete all of these files that just have been created. Hey, yeah, there we go. And then I'm going to modify our command so that it doesn't populate our root directory. Now, what is the command here? Well, basically what we want to specify is the output folder, folder, and then we can also like do something like that, equals, so we can directly provide a value, dependencies. I just want to put them all into a subdirectory called dependencies. And if I add that to that, you can see that the command, first of all, it was faster because you can actually see that the requirements were now like loaded from the cache. So first of all, it's like checking the local machine cache, and if it's not finding a package there, it's going to go to the Conan center. Then it downloads kind of like the definition of the package. It tried to find the binary. The binary was not found on Conan, so it was compiled on the local system. Now the compiled binary is in the cache, and it can basically consume that from the cache directly. And you can see it's now fast. If we do not have populated files, we have all of them now in a nice little dependency directory. And since we are doing this all properly with git ignore, I basically now also want to say and ignore the Conan output dependencies. This is basically saying, all right, a dependency folder shall also not go on Git, since that one is also generated by Conan. All right, so now actually we are ready to use the SPD log, right? Because SPD log is now in our project. How can we use it? Well, we can't use it at all because actually the problem is we do kind of like have some generated stuff that is somehow setting something up and adding paths, not really knowing what they are really doing with an environment. But yeah. However, what is currently missing, it's the integration to our build system is missing. We are using premake 5, so we need some directive that we can put into our premake file, our premake5.lua, so that our dependencies are correctly added. And that integration is why we need Conan 2.0.4, because previously to that, the integration was not there in Conan, because basically the Conan team decided to not maintain the premake extension for Conan 2. So actually I had to write all the extension. I basically had to rewrite the whole premake integration so that it now works for the newest Conan version as well. Okay, so what we want to do now here is basically tell Conan to generate the project for premake. How do we do this? Well, we basically specify something called a generator. A generator in Conan is basically a piece of software. It's a module. Conan is modular. We can add as many generators as we want, and the generators are responsible to take all the Conan dependencies that we have defined in here, the requirements, and craft them into a format that the build system understands. And what we want to use is we want to use premake, so we need the generator premake, but not the generator premake. We need the generator premake deps for premake dependencies. This one is generating or converting the dependencies into a format that premake can understand. So the generator is called premake deps. This is the only line that you need. If you now rerun that command, you can see that we have a hell of a lot of more files in our dependencies. You can actually see that we have now a hell of a lot of .premake5.lua.premake5.lua.premake5.lua.premake5.lua.premake5.lua Conan depths, and somewhere also a Conan utils.premake5.lua. And all of these Lua files are now helping us to correctly integrate the projects. Now you can first of all see that we have some Lua files on the per dependency base. You can see we have one, or actually two for FMT and two for SPDlog. Now one of them is just called Conan_FMT premake5.lua, and if we would take a look in that, the only thing it does is actually including the file for the release configuration. If I go to my release configuration, you can see that we kind of like have an array here, and there's some carnage going on with that array, and that array is now actually including interesting stuff. For example, you can see the include directory. There's some very obfuscated include directory, and this include directory is actually a directory where Conan has copied and packaged the headers for, in this case, FMT. You can also see that the library that shall be used is called FMT. There's a binary directory for FMT, and there is a library directory for FMT. And if you would even want to consider, you can actually like copy them and open this up, and you would find like in the include folder the FMT folder with all the headers in here, or here's also the library folder with the fmt.lib. So everything is somewhere stored on the machine that has been copied and made available by Conan. Now, if you want to use that, you of course do not want to understand how the build system works. What you want to do is you want to use the root file. The root file is called premake.debs.premake5.lua, and this file is going to contain two handy functions, actually three handy functions: Conan setup build, Conan setup link, and somewhere down here Conan setup. And these functions allow you to easily integrate the dependencies for your project. Now, how does these functions work? Well, they are working really simple. There are two parameters. Both of these parameters are optional. You can leave them out at all. One is the configuration parameter. That configuration parameter could be, for example, release_x68.64. And the other one is the package, where you could, for example, specify that you just want to have FMT. However, they are optional. So what you really just need is you just need the Conan setup function and that include here. So if I would copy the file that I want to do here into my premake5.lua file, go to the, no, not collapse this. I actually wanted to go in here, go to the top and do an include. I want to include from dependencies. I want to include Conan debs.premake5.lua, and I want to then call the Conan setup function. I want to call that one on the project base. So if my project has been created somewhere down here, I might want to call Conan setup, and this shall set up everything for our Conan project. So now, yeah, let's quickly go and say premake 5 vs 2022, and let's run this again and see what it does. Actually, you can see that our project has been updated. If I go back to Visual Studio and reload that, you might think that you have SPDlog available. However, you do not have it. The problem is that what we have currently done is we've just acquired a release configuration from Premake. So if we would take a look at the additional include directories on Debug, you can see that they are empty. If I go to release, you can see that we are getting FMT and SPDlog in here, but we are only getting them in the release configuration since we just downloaded the release binaries from Conan. Now, there are multiple ways of fixing that. The most simple way imaginable would be to just manually provide the configuration. You can do this by basically just specifying release_x68_x64. This is basically in hard coding saying always take the release configuration. If I redo my premake command and reload it in here, and go now to my properties, we should always have them. You can see, yeah, I'm on debug, they are already here. If I go to release, they are still here. If I go to all configurations, they are here. And now SPDlog is available. Now we could try and start using SPDlog. So #include SPDlog. spdlog.h, and since spdlog is a very nice and easy to use library, we can just do a spdlog. Let's do a warning so that we get a bit of a nicer pattern and say hello world instead of our cout. And if I run this, yeah, I would hope that everything works. And it failed. Now, what is the problem? the problem that's currently happening is that we are using a release build of spdlog on a debugging build of our solution. So our fix doesn't work. It's a bit of a problem. Conan itself is designed, not designed to only do release builds. However, if you want to do debug builds, you need to do a certain trick. You need to trick Conan by thinking that you are on a debug configuration even through your profile is specifying a release configuration. Now, how do you do this? Well, you can actually tell Conan what configuration you want to use. Now, how do you do this? Well, basically you provide a setting. If you are using this settings argument here, you can basically override all settings that are defined in your profile. In this case, I do want to override the build type and set the build type to debug. If I do this, you can see that Conan goes on and does another build. You can see it downloads FMT again. FMT is running a build again, format.cc, os.cc. Now it's doing another build for spdlog. So you can actually see we are building it another time. The nice thing is that these two builds actually work together. Even though you need to run Conan twice, they work together. Debug and release work together. Conan can automatically detect that there's already a release build integrated. You can see that we are kind of like getting a few more files now with debug and release in here. However, if you take a look at this, both of them are included because Conan is aware that you actually already have a release configuration up there. So the only thing really that needs to be done is running this kind of like twice, and then of course removing the shortcut here again in the Conan setup, because this one is also designed to work with release and debug builds. And if I run this now again, happy little clouds, everything should work now. So if I do a build, it should now successfully build. With maybe some warnings, but that is a different story. The problem is that Conan is basically not copying the PDB files, and they are not discoverable by Visual Studio, so you're always going to get a bit of a linker warning there. I don't really like that this is the case. Can get rid of that. It's not 100% clean getting rid of that. Link options. I think it's called link options. And then ignore, what is the code? 4009, I think. Yeah, 4099. And I think it's the link options. Yeah, link options was already correct. I know, I would love, there are ways to actually get this done. There is something called a custom deployer that could, in theory, try to copy it, but we do not want to do this. This is not stock, so we can't use it. We just ignore this warning, and it's gone. I mean, it still does take longer because it's still trying to find these, but we're not going to get a warning, and that's what we are happy. And if I now should run this, we should get some spdlog hello world warning, and now everything is set up correctly, so a release build should also do the trick and should also work. And again, we get a hello world and warning, no issues about mismatch runtime libraries, and everything is good. Now, there's one thing that I still want to do. I want to quickly create yourself a so-called autogen, or maybe let's call it init.py. And this init.py script shall now automatically run all these comments, because it's a bit hard to memorize all these comments, especially if you are new and don't know how Conan and all that stuff work. We could make that command a batch file. However, I want to keep this as platform independent as possible. So what I'm going to do is I'm going to do this with Python. It's simple with Python. Just import subprocess. If name equals main, your default Python main, and then just do some subprocess.run. The first subprocess.run shall be the Conan subprocess.run. So let's run Conan install in the current directory. We want to build missing libraries, and the output folder shall be /dependencies. That's it. And then I want to specify the setting here, and the setting that I want to specify, maybe let me format this a bit nicer. So it's a bit better to read. And the build type, no, it's not like that. Settings equals, I think, what was it that? You see, right? Yeah, settings equals build type equals debug, and then we would need to copy and paste this. And since I hate copy and paste, I am going to do my def run Conan build type, and then I'm just going to copy and paste that in here. Why do you not format this correctly? I don't care. And then I want to, instead of putting this in here, maybe make this with a format string here in Python, and then put in the build, not the buffer size, the build type in here. And then what you can do is you can just do your run Conan with debug, with release in here. And then what you want to do is you want to run pre-make, and maybe, yeah, let's maybe make this also in a function so that we have a bit of a consistent pattern in here, and then we can run pre-make here. How do we run pre-make? Maybe let's add that one to that line here as well. Pre-make is just done by calling pre-make 5 in the root directory, and then we're going to specify the action here. So that's a really simple thing. And run pre-make can then be done with just like a hard-coded version of VS 2022. By the way, my library that I'm going to publish is automatically detecting the Visual Studio version, but that's really carnage to detect the Visual Studio version automatically, so I'm not going to do it here. Yeah, the only thing that you really need to do now is basically say Python, if you can write Python, init.py, and that this will automatically do everything that you need and generate your solution. Boom, done. All good. Now, after you have set it up your repository, your work is gonna be easy. Let's now imagine we want to now add something new to the project, for example, zlib, or let's add LZ4 because I'm more familiar with LZ4 for compression. So if we want to add LZ4 for compression, well, what would we do? We could now time this. Yeah, maybe let's time this. Let's time this, how easy we can do LZ4. Let's go to my stopwatch. Let's start it here. How easy do we get that? We go to Conan Center. We search for LZ4. There it is. We're going to copy the identifier of LZ4. We're going to go to our Conan file.py. We're going to write another self.requires, that's costing time because I'm an idiot, but that's a different story. So we basically require LZ4 by adding this in here. One bottom up, init.py Python, downloading FMT. FMT is copied to the source folder. Now it's building it by using CMake. Takes a few seconds. CMake is slow, but at some point it will hopefully build it. Yeah, then MS-build is run. It's building that library. It's doing this again for the release configuration, performing tests, performing stuff, and at some point this is done. Then MS-build runs again. It's compiling it again. And there it is, everything has finished. Now I go to my project, I click on reload, and I should already be able to include LZ4 and LZ4HC. These are like the compression stuff. And then I can do my std string. Std string is not included, but let's include this one. It is included because we have SPD log, but then we can like do my message, and my message is something like blah 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 blah, and then I could do something like get myself a bit of a buffer here into which I want to compress my stuff, and then I say auto size equals LZ4 HC. LZ4 compress HC is the come on. LZ4 compress HC. Deprecated compression function. HC2. Is it 2.1? Yeah, seems like it. HC2. Now I think it's also deprecated, but I think if I peek into, I should get that one. LZ4 compress HC. That's the one that I shall use. Okay, but what was it? scene is deprecated. Oh, no, it's not deprecated. Interesting. msg.cstring, msg.size +1, so that we have the null terminator in here as well. No, that's destination that we want to use. I am not good. Destination is buffer, source size is that, destination capacity, 1024, compression level, LZ4, C level, LZ4, C level, there it is, HC C level, okay. LZ4 HC, C level max for the maximum compression value, make a breakpoint here and run it, and we should have a compressed data. And there you go. My size has been modified, yeah, because I'm on release. That's not good. Of course, I need to be on debug so that I can see my size, so that you can actually see that it has done this correctly. And there we go. Size is 5.3. The buffer is of course invalid because there's some carnage going on in the format. It's of course not readable. But as you can see, we have done LZ4 compression. If I now stop my timer, under 4 minutes. Within 4 minutes, we have found LZ4 on the Conan Center. We have added it, we have compiled it for debug and release. We have added it to our project configuration. We have reloaded our project, and we have actually added some code. And I have done a hell of a lot of mistakes. If I would have tried this out, we might have even got this down like to just 3 minutes, and now we are under 4. So this is fast development, and this is how you want to do it. I mean, of course, nothing comes free, right? If you want to complain about that you need Python and you need Lua to do your project, sure, you can do about it. You can complain about that one, but I don't think that this is complicated on how this is looking. You just need to know how that works and how that works, and it's done. And you have good software. And if you're not the maintainer of the repository, you don't even care, right? If you're not the maintainer, that comment, and you are ready to go. Way better than CMake, way better than everything else. You have a native Visual Studio solution. Solution we can work with. It's not like CMake where the solution gets it placed somewhere else and adding new files and everything gets cocked. So it's good. So yeah, I hope you enjoyed it. I'm a fan of the toolchain. Can't change that. Never can change that. I like the toolchain. I like to work with it. It's simple, and that's it. So thank you for watching. If you enjoyed, please make sure to like and subscribe. And yeah, I'm gonna wish you a nice day. Bye.